Raj. Now we are going to see the complex number, higher secondary second. We completed the exponents 0.1. Now rectangular form. Rectangular form. So z is equal to, let, now I am taking a complex z is equal to x plus iy. Z is equal to x. We write in the form of, already we know that, a plus ib. So here we are writing z is equal to x plus iy. Here x is called real part of z and y is called imaginary part of z. So that is part, imaginary part of z. Okay, it's the rectangular form. Okay, now organ plane. Graph. So that is the graph. We already know that it's the real part and it's the imaginary part. In this axis, the axis means that real and imaginary part. So that is called organ plane. Suppose z is equal to x plus iy. It's a complex number. The points somewhere, it's the z. What is that? X plus iy. We are writing in the organ plane. So now listen. So z of x plus iy. Suppose now we are taking some values. 3 plus 4i. It's a complex number. How to solve this one? So 3 comma 4. 3 is the real part and 4 is the imaginary part. So what about that? 3 and 4 somewhere here. So 3 plus 4i. Writing 4i. How to write in the organ plane? Make it as a form of rectangular. We are going to write 0 plus 4i. So plus 4i. So 4i is imaginary. Okay, 0 comma 4. It's 0 comma 4. Somewhere here. Okay, 4. So 0 plus 4i. Okay, sir. Write 5 in the organ. So we are writing the organ. First of all, we make it as a form of rectangular. We can write 5 plus 0i. The imaginary part is 0. 5 comma 0. So that is 5 comma 0. So 5 plus 0i. So now this one is the organ plane. Now we are going to see the algebraic operations of the complex number. So what are all the algebraic operations? Now listen, but very fast. A scalar multiplication of a complex number. What is scalar multiplication of a complex number? Now z is equal to x plus iy. I will multiply a constant, k z. The k is belongs to some real number. K belongs to is real number. Kz is equal to k into x plus iy. So we can write kx plus I into ky. So it's the scalar multiplication. For example, that scalar may be positive or negative or a rational number. Okay, now listen. 5 is z. How to write it? Now what is z? Z is equal to, now I am taking z as x plus iy. X plus iy. Sir, this one is z. X plus iy. How to write 5 is z? Now listen. 5 into x plus iy. What will happen? 5x plus I into 5y. So it will be expand. So this is 1 comma 1. Now it's 5x and 5y. That is 5 comma 5 somewhere here. So 5x plus I into 5y. So this is called 5z. So it will be expand. Now it's positive scalar. Now a rational number, what will happen? It's a rational number. Okay, it's z x plus iy. So how to find half z? How to find half z? So z half into x plus iy, half into x plus iy. We can write x by 2 plus I into y by 2. So half of the given value. So it's 1 comma 1 like that. Now we can take half of that. So 1 by 2 z of, z by 2 we can write like this, x plus I x by 2 plus I into y by 2. So it's half of the value. Now what about the negative value? Now we are going to take negative value. Suppose the negative, listen, minus 5z. Now we know the z, x plus, we will take this one. See here, it's the 5z. How to write minus 5z? It's opposite, minus 5z. Minus 5 into x plus iy, what will happen? Minus 5x minus 5iy, or I into 5y. So where is 5? It's here. Minus comma minus, it's in the third quadrant. We can plot here. So minus 5z of, we can write minus 5x minus I into 5y. So it's the scalar multiplication of a complex number. Now the next one, addition of a complex number. It's very important thing, how to add the two complex number. Okay, addition. Now z1 equal to x1 plus iy1, z2 is equal to x2 plus iy2. It's the two complex. Listen, we are adding the two complex number. It's real axis and it's imaginary axis. So what about z? Z x plus, now listen here, we are taking named as z1 and z2. Now I am taking z1 as here, it's x1 plus iy1, z2 x2 plus iy2. It's z1 plus z2 comma x1 plus x2 comma y1 plus y2. It's the parallelogram law of addition. See here, it's real part and imaginary part. Now I am taking a number, suppose 3 comma 2 somewhere here. So that is 3 plus 2i. Okay, it's the first number. The second number, now I am taking 1 comma 5, 1 plus 5i. Adding these two complex numbers, what will happen? Now I am adding the real part, 3 plus 1, it's 4, 4 plus 7i. Plot that, 4 plus 7i, somewhere here. So, somewhere here. It's the parallelogram law of addition. The same manner. So sum of two complex number. So that is z1 plus z2 is equal to x1 plus x2 plus I into y1 plus y2. So what about that rule? So adding two complex number, we are adding the real part separately and imaginary part separately. Okay. Now the third one, subtraction of two complex number. Suppose we are taking the same thing, z1 is equal to x1 plus iy1, z2 is equal to x2 plus iy2. Just it's a, now see the geometrical representation, how to write that. It's real part, it's imaginary part. Yes. Now the same z1, z2. Now what is the process? z1 minus z2. How to write this one? z1 plus of minus z2. Okay, now we know the z2. What is minus z2? Minus z2, it's in the third quadrant. minus z2. Suppose, what about this one? This is x2 comma y2. Minus z2 means minus x2 minus iy2. It's in the third quadrant. Now listen, we are adding these two complex number. So we will appear there is a z1 minus z2. So it's the parallelogram. Using parallelogram law of addition, the subtraction is also the same thing. Z1 minus Z2 is equal to like that. Okay, how do you explain? X1 plus IY1 plus minus x2 minus I into y2. Okay, x1 minus x2 plus I into y1 minus y2. So it's the subtraction. The last one. Multiply a I value for a complex number. How to multiply as I? Listen, multiply by I. Z is equal to x plus iy. Now I am going to multiply by I. What happens? Listen, it's first quadrant. I is that. What will happen? Now I am going to multiply as I. Okay, I into x plus iy, ix plus I square y, ix minus y, because I minus 1. Now write in the form of rectangular, minus y plus ix. So that is iz, iz. Now I am going to multiply iz by I. So I square is z. Okay, I square is z. What is I square? It's minus 1 into x plus iy. So minus x minus iy. It's in the third quadrant. Okay, this is I square is z. So minus x minus iy. Now listen. Now I am going to multiply the I square is z by I. What will happen? I cube is z. So I cube is minus I into x plus iy. Okay, minus ix. So there is minus I square. So that is minus I square y. We know that I square is minus 1. So minus ix plus y. So we can write in the form y minus ix. Okay, so this is I cube is z. This is I cube is z. Listen, we are plotting this one. So this is z, x plus iy, I is z, then I square is z. It's in I is z. What is I is z? It's in the second quadrant. What about I square is z? It's in the third quadrant. I square is z. Again, I cube is z. It's in the fourth quadrant. I cube is z. So now listen, there is a angle made by 90 degree for each one multiplied by I. It's in the clockwise direction from the origin. So there is a 90 degree angle. Just multiply by any complex number, it will make a 90 degree angle from clockwise direction, anti-clockwise direction. Okay, now we are going to see the next one. I think it's exercise 2.2 in the next class. Okay, thank you.